Alrighty, Henry, can you hear me?
Yes, and you can hear me now too when I unmute myself.
Yes. Good. Yeah. So we'll try the raise your hands technique, and we'll see how that goes. And then if that is not working, we'll just have people reply in the chat, and
Yeah,
then we can
or
keep
we
an eye
make
on
it a
it.
shouting session.
Yeah, we'll make everyone turn off their mics, and we'll see who has the most feedback. So, alrighty. So this presentation came out as part of I was giving a talk at a conference in Los Angeles, California, and a person came up to me after the talk and said the talk was good, but it's hard to follow. It's very confusing, lots of topics, and so we came up with this together as like a way to give an interactive mainframe hacking presentation that is easier to, and that sort of makes the audience participatory instead of it being me just yelling at someone for I don't know an hour. So here we go. So this is experimental. I've given it maybe twice already, and it seems to work. So there are wrong answers. So just know that there's a path that we might go down that will lock us out. But so for those who don't know who I am, I'm part of the Mainframe Hacker Society, which all today's speakers are a member of. It used to be a secret society until I outed us. I don't know, earlier this year when everyone had to do virtual conferences. We did a panel for a conference. I do mainframe security research for a major American bank, and I currently do all kinds of things. I've spoken at, I've spoken at GuideShare Europe multiple times. We've done all kinds of things. Basically, I've spoken at almost every major conference except for those who don't know, the Chaos Computer Club has an amazing, like literally amazing conference every winter, and it just so happens it's between like Christmas and New Year's, and my wife will not. My wife would kill me if I just went to Europe for Christmas and New Year's just to go to attend a conference. So I also teach a class called Evil Mainframe. So that's in fact, Henry's helped us put it on before in Amsterdam. Where yes, you're right. The comment said that I could bring her along. Yes, but then I'd have to bring my two kids, and that's a long flight. So, anywho, we run a class called Evil Mainframe where we teach mainframe penetration testing hands-on with the mainframe, and we teach all the techniques, which we'll be covering in this presentation. So, okay, so how does this work? So this is a big experiment. You sort of learn the thought processes behind mainframe hacking. All this is fictional, right? It's supposed to be for fun. Obviously, it's not supposed to be some big realistic story. The attacks and the techniques that we use in this presentation are real, but the scenario is obviously very fake. I would not break the law for some strangers on Twitter. But again, this is very heavy audience participation. Please, I don't mind answering questions through the chat. If you have a question, I see it pop up on my screen, and then we'll have Henry sort of manage which direction do we go here. This is going to be all ZOS. This is pretty redundant for this conference, but typically, if I'm giving this somewhere else, some people in the room might think that this is a talk on, say, AS400, which this is not. So if anyone in the room is expecting AS400, I apologize, but that's not going to be happening. Some terminology. So I don't know what the mix is here of who's a mainframer versus who's a non-mainframer. And so I will keep the terminology in here. It's also good because it's being recorded. But so Rex is a scripting language. It comes on ZOS. It's just pre-installed. It's really good. I like it. I really like it. I prefer Python, but it's good. It's up there in terms of Python for me. Stems are kind of weird, but I really do like Rex. RACF is security product. Instead of things like who am I in typing, you might type LU. If you watched the previous presentation, you would have seen Jake, he typed LU. That's like the who am I command of the mainframe. And then JCL. In fact, I made a post on Twitter yesterday that made fun of people. making fun of JCL. Basically, like if you're trying to do any modern deployment of software these days, you've got to have a YAML file which describes how you log into and use a Docker container to build your product and then deploy it to prod. And it's just JCL. I mean, it's literally just like, what if we just took JCL and just made it with tabs instead of 2 slashes, right? Like everything old is new again. Alrighty, so let's get started on our adventure. So we're going to do some mainframe hacking. Alrighty, so you are minding your own business and you receive an urgent text message from 2 individuals who are well respected in the InfoSec, let's say underground hacking community. They need you to hack a mainframe for them. You receive this chat. It says, can you help us? Some kids are being blamed for money laundering and we need your help going after them. So you tentatively respond and you tell them what you need. You need some form of computer inside the enterprise that has access to the mainframe. So like not access as an account, but direct access as in can talk to the mainframe over TCP IP. You need Nmap. So Nmap is a port scanning tool. If you've seen any of my other talks, I've written scripts and everything for Nmap, but basically it lets you sort of map out what is running on that mainframe on the network. X3270, which is just a 3270 client or emulator that I use all the time, and Python. So the question was, are we going to use some of this information? I mean, I'm not going to tell you what information you'll need to know, but some of it you might. Okay, so you get that text, and then nothing happens. You tell them what you need, you say you'll participate, and then several days go by. And you get this text. They tell you the IP address, they tell you a username and password that you can use, and a list of cracked Windows domain accounts, and a target IP address. And they tell you the user that they're targeting. They're going after a specific user. They want you to get on the mainframe and target this specific user. They don't tell you what to target. They just tell you, we need whatever this user's got. So you write all this down, right? So this is typical when we're doing any kind of engagement on a mainframe. You would have your scope. So you write down what your LPAR is, right? So we obviously have an IP address. Now, mind you, they could have many different LPARs. In my experience, typically in a mainframe environment, you just need to connect to one LPAR. And if I can get to VTAM, I could probably connect to other LPARs, right? Just the way they've set it up. So we get one IP address and we get one user ID. And then we also obviously go check what's in the pastebin link, right? And if I can wait for people to go check it out if they really want to check it out, but you go to that link and you find that it is a text file with about 4,000 user IDs in it, right? So they've already broken into the domain. They've already been able to do some sort of password stealing, either through various Windows techniques that exist today, Kerberoasting or I can't remember. It's 4 a.m. here, so forgive me if I'm forgetting the other tools that exist for Windows hacking. But anyways, you get a file, 4,000 user IDs. Who knows how many are valid on the mainframe or not? First thing we do is we run an Nmap scan. So we boot up Nmap and we run this scan against the mainframe, and we only see this running. This is a fairly quiet and locked down environment. Now, this doesn't mean that all the ports are closed. So like it could be running MQ, it could be running NDM. In fact, it likely is. It's probably running NJE, but these are the ports that are open to you from the machine that you're on. Now we have a choice to make. So if you look at what's available here, we have FTP. We have 3 separate TN3270 listeners and an Apache Tomcat server. And again, everything that we're going to talk about are things that I've seen. So now we have a choice. And Henry, I'm gonna switch back to you so you can help the audience make a decision.
Right, let's see how that goes. So we get 3 options. We can either go for Tomcat, the web server, we can go for FTP, or we can go for 3270. So I'd say we go left to right. Tomcat favorites, raise your hand, please. And I'll give us like a couple of seconds. Sort by raised hands. In 5, 4, 3, 2, 1. All right. Now the question is, how can you unraise your hand? I don't know how that goes away, because otherwise we get like a fake double count. No. Could the people who raised their yeah, they're gone. So there are no more raised hands. Can I now see the hands? Oh, there are still hands. What is this? Well, what about FTP? Who wants to go for FTP? Oh, boom. That's a truckload more.
I can, it's funny. I can hear it.
1, 2, 3. Well, that's like loads.
Okay.
And then wait for those hands to disappear. Yes, can somebody who is raising and lowering their hand let us know if you actively do something, or does it just time out by itself? Unraised by clicking again. Thank you, Martin. Right, final call. 3270. Who wants to go attack 3270? That is an even greater truckload of people. So I would say the audience has picked 3270.
Alrighty. So we'll go after. I mean, that's not really surprising given the audience that is here. But okay, so we'll go after 3270, which would be my choice, anyways. Okay, so we notice that there are 3 ports running on TN3270, right? So you have port 23, port 992, and port 2323. If you remember back to the previous Nmap scan, you'll notice that only one of them was running with SSL, right? So it's a typical deployment that I've seen before where if you, the places, I don't know why the places do this. They have an SSL port and they tell other users they have to use that SSL port, but they never shut down the unencrypted port. Like, that's not great. But in fact, I run the internet mainframe program that scans mainframes on the internet, and I have like hundreds of mainframes that, well, maybe not, that's not an exaggeration, tens of mainframes that have a non-SSL port and an SSL port open for reasons over the internet, which is wild. But anyways, so you decide you're going to go after TN3270. So the first thing you do is you need to get a lay of the land. So you run TN3270 screen to look at what's running on the various ports. So we're running against port 23. Okay, this is a typical, boring, lawyery mainframe warning screen. Hey, if you connect to this, we can watch you, I guess. These things always bother me, and I once got into a fight with someone over why I have these warning messages. But so this is obviously what it looks like when you connect to the mainframe, right? So the purpose of using Nmap is it's just easier and faster from the command line. You can do multiple ports at the same time instead of having to go into connect to each and every port to see what's going on. It will also tell you hidden things, hidden messages maybe, or hidden options in the screen that you can't see in a 3270 client. And it'll also tell you your logical unit, which, I mean, you could just look at the screen here, but there's reasons why that's important in a bit. Okay, so you look at port 992, it's the same thing. So obviously this is a situation where they set up an unencrypted port and an encrypted port at the same time for whatever reason. And then port 2323. Anyone want to, I'm obviously not, well, maybe the chat does show up. Does anyone want to guess what port 2323 is going to show? Anybody? Oh, that's cheating. Anybody else? OMB, yes, that would be, if you can tell me how to set that up. So it's Kix. It takes you straight to Kix. So instead of it taking you to an app, like to just VTAM, it takes you straight to an application. That's interesting. I don't know why you would do that, but people have done it. So now we have another choice to make. We have to figure out what's going on. So on port 992 and 23, we know we're in VTAM because if you type IBM test, you receive IBM echo, and then a bunch of characters, which means you're at VTAM. Right? And there's things we can do in VTAM to enumerate application IDs, essentially silently. But the other one, though, takes us straight to kicks, and the logical unit is kind of weird looking. Right? So let's look down here, like looking at the previous port, you can see the logical unit is smog LU01. And then over here, you notice that the logical unit is BSLV LU01. Okay. A logical unit, so for those who don't know, and again, for the mainframers in the crowd, this is obviously high level. It's not supposed to, I'm not going to spend, I mean, there's books on SNA, but essentially just the logical unit is your terminal ID, and that's how you're assigned in the SNA network, right? So you can actually scan logical units to see if anything else is running on that port. So while you connect and you get assigned a logical unit, sort of like DHCP, you can in fact ask and say, hey, I don't want whatever logical unit you gave this terminal. I want my own logical unit, and here it is. And in fact, I was at a company where they were doing that to, instead of bypassing TPX, it would go straight to TSO, and then you could enter your credentials there in case TPX failed, right? VTAM, this is how you log on to an application in VTAM. I assume many people here already know this, but you type log on Apple ID and then the command. In fact, some of them you can pass data as well. And if the application ID exists, it connects your terminal to that application. So when we're trying to enumerate applications, I like to liken it to a web server where you're trying to guess URLs, right? So you're trying to guess sort of what applications are running in this environment. So we have another choice to make. Do we look at the logical units? Do we look at that kicks thing that took us straight to kicks? Or do we look at VTAM? The reason there's reason to look at both. I'll tell you the reason we look at logical units is we're trying to get past that kick screen. There might be something beyond that is interesting to us that no one has thought hackers could get access to. And then obviously VTAM is going to be our main entry point no matter what. But we'll leave the choice up to you.
Okay, well, your votes for VTAM, please. Okay, that's curious. If you would unraise your hands so the other people can vote for LU. Any LU votes? Yeah, that's basically.
Yeah, I can hear it.
The rest of them.
That's cool that I can hear the hands.
Oh, you hear the ping? Cool.
Yeah, I get a little like ping in my headphone. So I guess we're going with logical units. Alrighty. So let's take a look at that. So you use the nmap script lu-enum, and you scan the logical units between BSLV LU01 to BSLV LU99. Now this is done automatically. The script will see if there's numbers, and it will try to guess a logical pattern based on the logical unit, right? So if it sees, I think by default it'll do the last two digits 00 through 99. So you just need to run it, and it will run. And then you notice something weird at BSLV LU50, the application changes. So you can see that in the script output when we run nmap. You can see once you get down to BSLV LU57, it tells you it's got valid credentials. Right? So that means what the script is doing behind the scenes is it says, here's the screen we get originally when we don't provide it an LU, and you compare that with an actual logical unit that we provide. And if it changes, or if it's allowed, first of all, and second of all, if it changes, then we know we've encountered something that is different. But when we take a look at it, it's just going to be TSO. So here we go. So we're going to connect. We're going to connect with our actual logical unit that we found, and it takes us straight to TSO. Now that's not, I mean, who knows? Maybe we don't have access to TSO through VTAM. So this might be a way for us to access TSO if we don't have access to it another way. So we just sort of squirrel that away for now. But since it's just TSO, we want to see sort of what's going on in VTAM world. So we go back to VTAM and we try to find out what other applications might be running on this LPAR. So we use another Nmap script called VTAM enumeration to try to find application IDs. And you can see it's not very complicated to do this with Nmap. That's how long it took to run through maybe 30 application IDs. And there we go. So we found 3 valid application IDs that work for our environment. We have TSO, A06 TSO, and Kix TS52. Probably a good idea if we look at each as a group. So this is when, we could use the Nmap screen tool to do this. I just like doing it with X3270. It's just faster than having to, I'm gonna have to type it out anyways for Nmap screen. So there you go. So we see we have Kix, TSO, 2 TSO application IDs, which probably take us to the same place, and then Kix. So nothing too exciting. Kix, for those who don't know, is, oh boy, there's people going to be real upset about this. Is a web server. It's like the pre-web server. I was teaching a class once, and someone got like upset enough to call me out in the class that I called it a proto web server. But it really was a proto web server. If you think of a web server as, I have templates and I have data that I need to fill in that template with, right? When you think of dynamic websites today, I have a template, I need to fill it with data. That's what Kix was, except it's COBOL, and the template is a map written in assembler. So it sounds different, but it's really the same. In fact, Kix, it really was the proto web server. The only difference is server, you don't have servers, you have regions. So instead of Apache Tomcat server, you would have a Kix region. And then instead of URLs, you have transaction IDs. And a transaction ID is 4 characters long. So the address space is not very long. You can enumerate them all in a short period of time. TSO is like the bin bash of the mainframe world. It's just your shell. Alrighty, so with that in mind, we have another choice to make. Do we take a look at Kix, or do we look at TSO? Before I let the vote happen here, I'll tell you from an attacker perspective why we'd be looking at each, right? So obviously TSO is the easiest place for us to look at, to go after an account, right? That's going to be an interactive account, something that we can use. Kix, you might not get an interactive account. However, if I'm a bad actor and I'm going after data itself, not going after, trying to take over the mainframe, I might go look at Kix first. Also, I might look at Kix to see if it's misconfigured. If I have an account in TSO, but the account can't do anything, who cares? But if I can find a misconfigured Kix region and use Kixpwn to launch a reverse shell that runs as the started task of Kix, well, that's a different story, right? So there's different reasons why we want to pick both. I saw a question come up. Let me see about Metasploit. Let me try to answer that. Let's see here. Isn't the Metasploit framework a more efficient way to do all this? Not really. In terms of Metasploit doesn't. So Metasploit has some of the tools that you could use. So you could run the Nmap scripts through Metasploit, but Metasploit doesn't actually have a TN3270 emulator. It also doesn't have. All the Nmap scripts you could just run through Metasploit, but as we progress through the rest of this, you'll see like Metasploit you could use it to get a reverse shell through FTP. That's right. So far, the only exploit that works against it. Also, if we had picked the Apache Tomcat route, we may have seen that you could have used a Java Metasploit module from the Metasploit framework. But unfortunately, as it stands today, Metasploit only has like really one sort of core attack in it, and it has a bunch of reverse shells that you can generate using Metasploit. But other than that, it doesn't really speak TSO. It doesn't speak TN3270, so on and so forth. Yeah, it could be useful for pivoting if you're talking about pivoting into the mainframe. But again, there's no tooling that exists in Metasploit to generate auxiliary sort of things on the mainframe itself. Like you're not generating a proxy through the mainframe with Metasploit. Alrighty, so with that in mind, now that everyone's had a good chance to ponder their decision here, Henry, you want to take it away?
Yeah, sure. Let's do it right to left this time. Any voters for TSO? You should hear a lot of pings.
Mm-hmm.
T1, 2, 3, 4, 5, 6, 7, 8. A good 9 of them. This is also a good test to see who's still awake in the session, huh?
Oh, yeah.
So if you'd be so kind to click again to lower your hands, and then any takers for a kicks attack or CICS.
Oh, right. Sorry, I should have said while you're tallying. Where I'm from, I'm from Toronto, Ontario, Canada, and in that region, they called it kicks.
Oh yeah, but the Netherlands is the same, Phil. So for a guide share meetup, you're all good.
It's just so funny because it's such a regional thing. Some people call it, like, depending on where you are in the United States, some people will call it CICS. One time I gave a whole talk calling it kicks, and someone was like, "Did you mean CICS?" I was like, "Yeah, all right." Like, you can see it. Anyway.
I think the CICS/kicks barely won the vote.
Barely. Oof, that's good. There we go. There's the final. We got one last vote in. Okay, so we're going to go for kicks here. I'm going to take a look at kicks. It's a good idea. All right, so you connect to kicks and get presented with the good morning transaction. We've seen this already, right? It's just a kicks screen. So now we have a choice to make. Oh, this is great. So do we want to do enumeration or brute forcing? So we can either enumerate all the kicks transaction IDs. Do we want to run a program that will enumerate all the kicks transaction IDs? Or do we want to take that list from Windows, the Windows domain accounts, and see which of them have access to kicks first before we do anything else? So do we want to try to enumerate transactions or go after user accounts? I don't know. Take it away.
Well, do we want to enumerate transactions? Raise your hands now. Okay. Wait for them to disappear. And then, let's see, there's 2 still up. That's all right. And any takers for a brute force user attack?
That one's more decisive.
The votes are through the roof.
You can just hear it.
So we're going to brute force the users, Phil. Take us away.
I guess so. So there's using an mmap script called kicks user brute, you begin brute forcing user accounts using the list of Windows accounts. Of that list, only about 10 of them had access to kicks. So that's noisy. And you notice that you only have 10 accounts, which is typical when you're doing this kind of work. Not everyone in the Windows environment will have access to kicks. Or they might not have the same password, right? So what we're using here is called a password stuffing attack, where you take a known valid username and password from another system and try to use it against a system that you're not sure if they have an account or not. And so we get 10 valid accounts, and we manually check to see if they have access to the CEMT transaction ID. CEMT, again, this is for people who aren't familiar with mainframes. It's like the PHP info for Kix. If you're a web developer or a web hacker, that'll mean more to you. But basically, it allows you to get a lot more information about the system than you can get from anywhere else. So since we figure out that one of the accounts actually does have access to CEMT info, we decide CEMT. We decide to run the script CEMT info and see what we have access to. So we're going to run this script against the mainframe and see what we get. So you can see at the bottom of the screen here, it's running all these queries against the environment. So you can see inquirer, all kinds of stuff. And then there we go. So now we get a list of all the transactions, the program names, the level, the system install date, all kinds of information. We can see everything that's installed, where it's coming from. For those of you who use ZPDT, this might look familiar. But so now that we have that, maybe it's time to let's take a look at, see if we can run something in that environment, right? So we see that CEDA is enabled, of course it is, and we notice that we have access to that transaction. And we did that behind the scenes. There's no script to check that. I mean, you could use the enumeration script to check your access to these transactions. So CEDA allows you to do a lot of things. It's basically like Tomcat deploy. So I can create, like, you can add transactions. So if the program exists somewhere, you can use CEDA to add it to Kix along with the right resource pools and stuff like that. But interestingly enough, IU figured out many years ago, like 3 years ago, that you could use it depending on the setup to submit JCL. So Kixpwn exists. So you as the attacker, I guess, the royal we clone the repo. There's a Kixpwn repo out there on GitHub. You clone it and you run it to see if we can get a reverse shell in the environment. So again, this is a tool made by IU. What it does is it uses CEDA to basically take some Rex, wrap that in some JCL, submit it through CEDA, and then have it execute on the LPAR, and it sends a reverse shell over Rex back to our environment. It uses CEDA to do the work. It's a good question. So you execute Kixpwn with the flags. So there's a whole bunch of flags for Kixpwn. But basically -S means we're going to submit a job. We're going to submit the job direct TSO. That's a file that exists on your local machine. And then we're going to open up port 4445. And then actually, I think direct TSO will call back to us. So it'll phone back to whatever machine we're on. And then this will upload and then run a rec script, execute it through JCL. So here we go. So we're going to run Kixpwn, and it's going to upload the data, and that's it. So that's done. So it's already uploaded. All we needed to do was provide a username and password, and then we're done. And then we run the netcat command to connect to that port. So we're going to connect to port 445, and now we're in a Rex listener shell. So you can see we run LU. This shows the user ID that we're running as. Let's see. So what user are we? Eventually we'll figure it out. So there we go. So we're user start 1. That's weird. That's not the user IDs that we had, but that's interesting. So we notice we have a shell as user start 1. The first thing we do is we try to create a new user with that, but this command gets denied. There's other things you could try to do, but it's just easier to just create a user ID, see what level of access you have. You start moving around, but basically the problem with Kixpwn is that the shell is really, really limited, and accessing files is a pain. It's not easy, and so it's unless it's a really powerful account, it's not really worth your effort to do much more. So it looks like this account is locked down because it's running a Kix region. So we sort of leave it alone. We say, okay, it's good. Well, we'll keep this in mind in case we need it. So that's sort of like another dead end. Yeah, so mainframe hacking is not easy, right? So it's not an easy thing to do, and you do end up hitting a lot of dead ends. So I guess we're just going to end up looking at TSO. So using the list of users from Windows and the nmap script TSO enum, we see before we run our brute forcing attack, we run this TSO enum to see how many users actually have access to TSO, right? Because it might not be the case that a user on the Windows environment actually has access to TSO. And it's better to enumerate those accounts and then run our brute force than it is to run our brute force attack, right? Because they might be watching for brute force attacks. They might not be watching for this account does not have access to TSO, right? So there's just reasons to do this. So after we do our enumeration, we notice of the 4,000 Windows accounts that we had, only about 20 of them have access to TSO. So we ran the script, and it came back showing only 20 of them. Now then we use another tool called TSO brute to attack and take. So we take all those 20 user IDs and we do a password stuffing attack where we know their password on Windows. So we just type that in TSO to see if it works. Now, obviously, I'm not going to type that in by hand. I'm going to use another script called TSO brute to make this piece easier. And to our surprise, only one account worked, which is infos 10/demo. And this is going to run, and we'll see our level of access here. So we run it against the script here, and we notice one of those accounts shows up. Now, obviously, this is more than just one account, but our infos 10/demo shows up here at the bottom. So you log in with TSO with the account and password demo, and the first thing you do is you see if you can get information about the user plague using the LU command. Whoops. You're not authorized to list any information about that user. Obviously, you're not running as any kind of super user or anything like that. Well, looks like it's time to do some system enumeration now that we're logged in. So we download all the tools from enumeration. So this is a live Git. You can download them now if you want. But we download the tools from enumeration, and there's multiple tools in there. But we're only going to use these three for now. These are the first three you're going to use typically in any engagement. We're going to run enum, search rx, and then apf check. Now we have a choice because they're noisy, and so some of them are noisy, some of them are not. So we have to be careful which one we choose. So enum is a rec script which gathers system information for you to help you target better. So say it'll tell you, here's where the RACF database lives. Here's all the SVCs that are installed. Here's a list of all the APF authorized libraries. Here's all the users that are logged in to Unix. But thanks, WDay, for implementing that. There's all kinds of information it grabs, right? And it uses calls to memory, so it goes into storage to pull that data, so it's relatively silent. There are some checks that it does that are not so quiet, but I'll share a funny story. I was doing a product demo, and they said, oh, run your tools, and then we'll see what we can detect. And so I ran this tool, and they said, oh, we didn't detect it. I was like, well, yeah, because it's just pulling in regions of memory I'm allowed to read. What would alert on that? And you're not going to log every time someone looks in memory. So anyway, so that's enum. Search rx is a really simple rec script that just runs a bunch of racf commands and checks your level of access to those searches. It's super bare bones. It's not supposed to be an all exhaustive search. I mean, someday I'd like it to get there where it just does, you type it and it goes and searches for a whole bunch of things, but right now it's super bare bones. Doesn't need to be much more if we're looking for simple things. But because it's using the racf search command, this could get you caught, because if you don't have access to run that command, it's going to run it a bunch of times. That could generate alerts. Could being the operative word. Sometimes it doesn't. So, well, it'll generate alerts, but the people might not be watching for it. Right? Like, oh, this user typed search rx 150 times. Who cares? And then APF check. So this program uses assembler and JCL and tries to check your access to APF authorized libraries. The reason we do that in high-level assembler is there's a couple of reasons, but the most important reason is because we don't know. I mean, we know it's running on RACF, but when we wrote the program, we didn't know what the environment was running. So we needed something that was, ESM agnostic. So it uses rack route to check your access to a data set. rumors have been told that that will not create as much noise as trying to directly access the APF authorized data set. I don't know if that's true or not. I haven't encountered an environment that watches APF authorized data sets as closely as I would like them to. But this tool, basically what it does is it pulls from memory the data set for LDAPF authorized libraries, and then does a rack route to check your level of access to it. And then it just prints out a list of which ones you have access to. For those who don't know, an APF authorized library is essentially a folder. Look, this is high level for non-mainframe people. A library is essentially a folder that has an APF authorized library is a folder that anything you put in there can get into ring 0. Okay, so it becomes key 0, which means it can do a lot of stuff, right? But essentially it means we can, from an attacker perspective, that's important to me, I can overwrite regions of memory that are write protected. Okay, so we upload all the tools using $file. We use FTP upload because FTP was available, and I'd much rather use that to upload the files. If that wasn't available, we could use $file. If that wasn't available, there's like a billion different ways to transfer these files. They're not very big. I can just copy and paste them in. There's a whole bunch of ways to get them up there. But basically, we upload these files, APF check, search RC, and enum, and now we have a choice.
Oh, that's me again.
That's you, Henry.
Right, show of hands for a APF check, please. Well, 5-ish. Who would like to go for little raccoon for enum? Woohoo. Wait for them to disappear. And then search RX. The fast bunny, or probably a hare, huh? Well, I'd say people were paying attention, but enum wins by a stretch.
Oh, good. Alrighty. Then I'll address the comments about supervisor mode and key 0 in a second. We'll get there. Okay, we'll run the enum script here. So we run enum and we pass it the argument all. So there's an argument you can pass. It takes all kinds of arguments, but just to save time, we just pass it the argument all, and it goes through all the areas that we care about. So this is going to execute it since we've already uploaded it. And now we're going to dump it. So here we can see, okay, so we have the location of the Rack databases. We can see all the security settings within, and again, I don't have access to run like setter ops or anything like that. So we can see the jobs that are running. We notice that the start one user is also running other things, interestingly enough. That might be something we could use later if we need it. Let's keep going down. And we can see a list of all the APF authorized libraries and all the installed SVCs. Other things, we type test up, we can see user home folders, lots of users. Notes all kinds of information in here. Okay. Did we get any information from that? That start one account looks interesting. Maybe we could do something else, but nothing really jumps out of this. There's, the RecF database was there. Looks like we could check if we had access to that. That will definitely raise alarms, I would hope, if I started poking around trying to access that data set. But I guess, Henry, I'm not going to make people, unless people really want to vote, unless you really want people to vote again, I'm just going to go to APF check.
I'd say do that, Phil.
Yeah, I think 2 people voted for SearchRx. So let me put this out there for the chat. Does anybody want to see what SearchRx does before we go to APF check?
Come on, just show it.
There's really it's just pure silence. All right, we'll do search RX, knowing that if it does anything bad, we'll get a mulligan. Okay, so we execute the search RX script and find some interesting things. So the first thing it does is find some data sets in warning mode. So evil.garbage, Karen.login. It's weird. And then we notice we have some BPX super user type stuff. Data sets in warning mode. Basically, it means even whatever the security permissions are on that resource, it generates a warning and then gives you access anyways. Right? There's reasons why that exists. I'm not going to get into them now, but know that if you find data sets that are in warn mode, you can go back and then so we check out these two other files. We don't find anything of value. BPX super user has the ability to sudo root, but I'm not going to go down this path any further. We'll go back up to our choice here because I know that's going to lead us down the wrong path, and everyone voted for APF check. So we run APF check, and it comes with built-in JCL, comes with everything you need to run it, and we look at our output in SDSF. So we run this tool, and we look at the Go output in SDSF, and we can see there's a whole bunch of APF authorized libraries. So we run the tool, and we go to the very bottom of the list, and we notice there's one data set that gives us update access. So, oh, sorry, I didn't realize it was a private comment. Alrighty, so we have an APF authorized library now that we can access. We have access to TSO. How can we take advantage of this, right? Like we can't, for those of you who know all about the mainframe, you cannot run an authorized program in TSO just willy-nilly, right? So we have to find a program name that is authorized to run when we're in TSO. And how do we do that? Well, we go and we look at the TSO auth. So if you have access to run MVS commands, which most people do for some reason, I might go and say, show me the TSO config, right? So show me what I have access to in terms of TSO auth. So there's a whole big output to get the TSO options. And I would look at TSO auth, and I would look at the list of program names within there. Now, all I need to do is compile a program that does a rack route. So I can put in any user ID I want and say, I'm going to go into supervisor state, I'm going to go into key 0, then I want you to do a rack route and give me the user ID plague. I'm going to call that program IOECM because that program is in the TSO auth list. So it doesn't matter which data set it lives in, whatever data set that's in, so long as it's called IOECM, I can run it and get auth. And it's a very simple program. It's like maybe a couple, like 20 lines of assembly. Right, so we do that, we compile it, and if you don't have access to a compiler on that LPAR, we would compile it at home and then put it in an XML file and then XML it and then transmit it up. Do whatever we want, but it doesn't matter how we get there. We get to the point where we have this program sitting in sys2.oldlib called IOECM. We run the program, and this basically what it does is it's going to overwrite our user ID in memory, like that, the ACEE, and it's going to replace it with user the plague. So we're going to replace, sort of like if you're used to like Unix environments, like replacing your user ID, like your effective UID, to a different user, right? The only problem is when you do this, you lose a lot of stuff in TSO. You cannot run ISPF because things have been changed in memory. So we can't use the file browser. So we also need now to upload a separate tool called cat. This super, super simple rec script. It just says, take an input file, you pass an argument, take an input file, dump that to the screen. And here we go. So here we are, we're running as user info S10. We execute. that script. So you see, we try to access the file. There's a garbage file, and we don't have access to that file. Okay. So now we're going to call our program that we've compiled that's in the APF authorized library from TSO. That's it. It's done. It takes 2 seconds. And now we are user the plague. Now it doesn't matter if you've noticed that user has access, operations access. So now we can do anything we want. And now we can read the file that was uploaded to that we didn't have access to before. So we take note of it. We copy it off the screen, and we did it. We found the evidence that our friends who sent us a message what feels like 2 years ago. We package all that information up. We take all the details of our breach, and we send it all off to Razor. We close the laptop that we were using. We leave the coffee shop and go home, knowing that we've done a job well done. The next day, you decide to watch a movie on HBO when all of a sudden the signal cuts out. The screen goes dark and is replaced by a teenager, and you happen to recognize the number at the bottom of the screen. If you recognize it, it's from that dump that we got in the previous, after we got APF authorized. Yeah, we did it. Now, obviously, this is a made up scenario, right? It's just for fun. I'm not telling people to go break into mainframes, but everything that we talked about works. I can't say I've used it in this exact configuration before for a successful breach, but I think we're going to see examples of that in the next talk. Are there any questions? I'm going to expand the chat here since I can't see the chat that was going on. There was a question about does searchrx test for bpx.file attr.apf? I don't know, actually. I don't remember. It's been a while since I wrote it, and so if not, I'll definitely be adding that. And for those curious, bpx.file attr.apf is it's a resource that determines whether or not you can declare APF authorized programs in OMVS or Unix. So depending on your level of access to that resource, I think it's in the facility class, then you can create APF authorized programs in OMVS, and literally the HFS or ZFS files for Unix don't need to be APF authorized. So you can create APF authorized programs in Unix without it being in an APF authorized data set. It's dangerous. Any other questions? I'm slowly looking through the chat here. Oh, no, I don't see any other questions. Well, Henry, again, I want to thank everyone for participating. This is always a fun talk to give, so it's nice to see people were participating and were interested in seeing what was going on. If you have questions, if you want to see all the tools and everything we talked about, there's far better tools coming up, honestly, in the next talk. So I would probably wait for that. But if you're interested in my GitHub is mainframed, and I put all my tools there, and I post a lot of content on Twitter. Most of it is not mainframe related. I will caution you there, but typically if I do release something on the mainframe, it will be through Twitter, since I don't have a blog anymore. Recently, I just released. Now, this is not InfoSec related, more just an art project. But I released a Kix program called Doge Kix, which is a Kix interactive Kix program to view and send your cryptocurrency using Kix. So And with that, thank you everyone for letting me speak. Thank you, Henry.
Thank you, Phil. Awesome talk. Let's try the show hands buttons again. Are we all fit enough to continue? Do we need a little bio